Hi guys, we're going to be solving for the nodal equation of the circuit. So I'm going to be using KCL. KCL is basically the sum of currents going to a particular node is equal to the sum of currents leaving that node. And I'm going to be representing current as the normal V over R, but this time it's going to be V higher as the higher voltage minus the lower voltage. The voltage will be measured across a resistor. So this is the formula I'm going to be using. So the first thing you want to do is that you want to identify your nodes. Let's come to the circuit diagram. This point, you may be tempted to say this is a node and this is a node. Well, guess what? This is just a wire. So it's just one node because it's just a wire that is there. I could have just come from here and connected it directly. It won't make any difference. It's just a wire. So this is our first node and this is our second node. So now I'm going to start picking my current direction. The current direction in this case will be at this node V1. I can see that this current is leaving. I can see that this current is also leaving. I will also assume because these are not power sources that also because these are resistors, power, they're not supplying current, so current will definitely be leaving this branch to go and drop across them, and as well as this. So in this case, we only have all the currents are leaving, so it's going to be at node V1. The first current leaving there is the 3 amps plus the 2 amps plus this one that is leaving at this point. So I told you that I represent current as V higher minus V lower. So in this case, this place will be the higher voltage, this will be the lower voltage. By the way, this is ground. So at this point, V voltage is equal to 0. So the higher voltage here is going to be, let's call it, it's going to be V1 because the name of this node is V1 minus the lower voltage is at this point 0. You don't need to write V1 minus 0 all over the resistor 2 plus this particular one. The node here is the same thing as the node here because this is just a wire. So don't start thinking this is a different node. It's just the exact same node as what is here. That's at this point. So this is going to be V1 because voltage drops across the resistor. So at this point, the voltage is lower when it drops. Sorry, at this point, voltage is higher. Then after it drops, voltage will be lower at this point. So it's going to be, this point is V1, this point is V2. So it's going to be V1 minus V2 all over 5 equals to 0 because there's no current entering the circuit. Remember, it's current leaving equals to current entering. Now simply just multiply through by 10 to kind of simplify the equation. It's going to be 20 plus 30 plus 5V1 plus 2V1 minus 2V2 equals to 0. You can simplify this to just become plus 7V1 to be honest. Yes, and this will become 15. So this will be our equation. Now at node V2, because now you only just focus on the nodes, that's where you get your KCL equations. So at node V2, let's see what's entering. We can see that 2 amps is clearly going to enter the circuit. We can see that the current at this position will go like this and come to this point. So that means this is entering the circuit as well. And guess who's leaving? R3. It's going to be leaving the circuit. So it's going to be what's entering 2 amps plus what else is entering? The current here, which is going to be V1 minus V2 over 5. I already taught you here. Equals to what's the current leaving? What's this point? V2 minus this is 0 over 4. Now simply going to multiply through by 20 just to simplify the equation. So it's going to become 40 plus 4V1 minus 4V2 equals to 5V2. As you can see, these are both simultaneous equations. You can solve them in your calculator. V1 will become equals to minus 6.173 and V2 will be equals to 1.46 volts. This is simply the answer. If anything you do not understand, do not hesitate to ask in the comment section.